Hello guys, and welcome to this hands-on session on using some basic stats procedure in SAS. So let's just start off with a new code. In this case I want to illustrate proc univariate. So if we just go and recycle this basket underscore stats dataset that we've created during the previous lecture, you'll see that you've got all these variables for each basket, and we just want to run some analysis on that dataset. So that dataset will serve us during this session. Okay. So proc univariate data equals basket underscore stats. So that's the dataset that we want to use. Then we want to use plot and normal, so that we also test for normality options. We want to analyze the variables sum of spend and max spend, so max SPD. So if you just go run, so very simple proc univariate, but you see that you get there lots of output, so moments where you have the kurtosis, the variance, the skewness, the mean. If you don't understand what some of these mean, don't worry. You got their quantiles, your extreme observations where you can check for outliers. You get some plots there, both on the histogram and the normal probability plot. If you don't know what that means, don't worry. You could get some nicer plots by using other features, but for the time being that will do. And then you can test for locations. You've got different tests for normality of your data, and really a raft of things. Okay, so this is just really an illustration of the power of proc univariate. Okay. Now if we move on and we start off with the proc frec, so let's just rename that, and what I want to illustrate is the two-way feature that comes with proc frec, allowing you to do cross tabulations of your categorical data. Okay, so if you just go proc frec data equals retail underscore purchases comp. So in this case I'm not going to be using the basket stats dataset. I'm going to go back to this retail purchase dataset with the product type already added to it, and I'm going to tabulate the store key and then cross tabulate this with the product type. Okay, so that's what the asterisk there is doing, really cross tabulating these two. So if I run this, there you go, I get basically the table of store key by product type, and it's really telling me the frequencies, the percent, the row percentages, and the column percentages. So really churning out lots of output, which I can then take for further analyses. Okay, so if we create a new program, and let me just rename that, and I want to illustrate proc core, so I'll just rename it proc core. So we'll go back to using our basket stats dataset. So we'll just go proc core data equals basket underscore stats, and then the var means SPD, so that's the variable I want, the base variable, let's put it that way. Then we need a with statement because we want to correlate the mean SPD with the sum SPD and the number underscore TRX variables. So we specify that, we run it, and we'll see that basically the proc core churns out those correlations. So you see that the mean SPD variable really has a significant correlation with both the sum and the number of transactions on each basket, as you would expect. So the higher the mean, that means overall you have more spend and more transactions on that basket. So nothing overly surprising there. Okay. If we then continue and start off by creating a new code, so in this code I want to take you through proc reg, so a sibling of proc core, but a lot more complete in the sense that it allows you to build regression models. So let's just go proc reg data equals basket stats. And what I want to do is I want to regress, so I want to build a model on the sum of spend or explain the sum of spend with the quantity, because I'd expect there to be a strong link between these two. So I'll just use a model statement for that, and then I'll use a plot statement so that I get a visual inspection of that data. Okay, so I'll just do plot sum SPD asterisk sum QT. So very simple model specification, really just a very simple regression model. And there you go, that's the output you get. So you get your model, so the number of observations read and used for the construction of your model. You get the analysis of variance, and then the parameter estimates on your model. So because you can see that the parameter for sum QT is significant, which basically means that yes, it's a very significant parameter in the so the quantity is very significant in explaining the total spend. And there on the plot you see that there's a neat correlation between the two, and this is really sort of what you'd expect. Okay, so there you go, just this very simple model that we've just built between those two variables. Okay. You could also use procreg for multiple regression models, but you won't go into that. That's more of an advanced application of SAS. Okay, so if we just go proc ANOVA, so that's the last stats procedure that we want to illustrate. So before that, we just need to prepare the data for the ANOVA procedure, because we want to have balanced data. We won't go into an awful lot of detail around unbalanced data samples. It's not really the main objective of this course, of this session. So let me just go proc summary data equals retail underscore purchase underscore comp anyway, then class store underscore key basket key, and the spend, which is the variable that we want to compare between two populations with proc ANOVA. Let me just output out a store underscore basket data set, where the sum of spend, I'm just going to rename that as total underscore spend. Let me just print that result. So we should just have basically for each basket key within each store the total spend made on that basket. And then what we want to do is we want to compare with the ANOVA procedure. We want to compare, is there a difference between the total spend for each basket across two different stores. Okay, so you can see that you get these two automatic variables generated. So I just want to drop those, so I'll just use that shorthand notation. So let me just change that and rerun that. And there you go. So here you really have, for each store, for each basket, bought in that store, the total spend. Okay. Now let's just compare the number of observations in a very sort of quick and dirty way. So let's just create a new data set called store underscore 1. Okay, and then store underscore 2. Okay, so we're using basically a data step to create two data sets. Okay, so this is also a useful illustration of this feature. So we're going to read in the store underscore baskets data set, and then we're going to use if processing to say that if the store underscore key equals 199, then output store underscore 1, else output str underscore 2 data set. Okay, so this means we have two data sets that are being sort of created from this store underscore basket data set, by sort of splitting based on the store key identifier. And then data str1 set store underscore 1. Okay, and what we want to do is if n, so the underscore n underscore variable, if that's less or equal to 1700,698, we want to keep that observation. We're doing this to make sure that both data sets, so the str_1 and the str_2 have similar number of observations, okay, because the store1 originally had more observations than store2 on the original data set. So if we just do proc contents on those two data sets, we can now see that str_1 has exactly the same number of observations, 1768, as str_2. And we're doing this to make sure that we have balanced samples to compare during our ANOVA. Okay, so now we've got just one thing left, which is to basically create this all_stores data set, where we're basically stacking up each of those data sets, so the str_1 and the str_2 data sets on top of one another. And we did this, as you well know, by using the set statement. Let's just do a proc contents very quickly to make sure that all went well and that we have the total number of observations that we're expecting. And then just print out the first few observations of that data set. So we'll do that. And just give it a second to churn out the results. And there you go. So if you scroll down, you'll see that you've got here, the double of what you had on each data set. So the total number of observations is okay. And here's the printout showing you that you've got what you basically were looking for. So all's good to go to run your ANOVA. Okay. So if we just go proc ANOVA, then data equals all_stores. And then we just go class store key, i.e. we want to run a comparison at the store key level. And then what we want to do is, we want to use the model statement to say, hey, compare the total spend across the store keys, okay? And means store key, and use a t-test and the two-key test to compare the figure, basically the total spend. Okay, so a t-test or a two-key test comparing the means, okay, of those two populations. Okay, so if we just so that's really important model, and then the mean statement, which is basically telling you the comparisons that you want to carry out. So if you just run that, proc ANOVA basically will produce lots of output that allows you to interpret the differences between these two populations, these two stores. Okay, so in there, there you go. So you've got two levels for the store key variable. Total number of observations read for each is the same, so it's a balanced sample. Then you've got the F value there for the ones of you that are familiar with the ANOVA. The F value for the total spend is quite significant, so there is a substantial difference between the total spend across both of those. And then the t-test and the two-key test that are basically telling you, running the same comparison, and they're both telling you that there's a difference. Okay, so that's pretty much it, guys. Just a very quick overview of some basic statistical procedures, and I will see you in the next lecture.